Hey, how you doing? My name's Elton, and welcome to the show. So this is the third in this month, are all about Windows containers. So every month, this show, the format is each month is the same. There's a common theme, and I do 4 episodes around that theme. We've done the introduction to Windows containers. We've done building and packaging apps to run in Windows containers using things like MSIs for pre-built packages, and then building from source code using those SDK images that Microsoft provide for us. In this episode, we're going to look at running these Windows workloads in the cloud in managed container platforms. So this is the goal for a lot of people with their existing Windows estate. They want to be able to package this stuff up, move it out of the data center, or move it to a different cloud, but in a way that makes it easily portable in the future. So when you package these things to running containers, ideally that's kind of the last big migration you'll do, because you can run them in Docker, you can run them in Kubernetes, you can run them in a managed container platform, which doesn't require you to look after a cluster of your own, to not worry about the virtual machines that are actually hosting these things. That's what we'll be looking at today. So this is ECS-W3. If you're new to the show, welcome. I hope you find this useful. We run for kind of 30, 45 minutes. It's very informal. There's no script. There's no editing that happens afterwards. It's just kind of all out. There's a Q&A, so if you've got any questions, put them in the YouTube chat, and I'll pick those up as we go along, or at the end if I run out of time. And then everything that I'll be going through is very demo heavy, and all those demos are up on GitHub. So if you go to eltons.show, that's the homepage for the show, you'll find the links to all the episodes, and you'll find the links to all the stuff on GitHub. Every episode tells you the prereqs that you need to follow along, and the code commands I'll be putting in, and all that sort of stuff. So if you want to check this out yourself, you can. Okay, so I'm going to switch over to this camera. I'm going to pull down my green screen, and while that's happening, I've got a very short advert, and I'll see you in about 20 seconds. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. While I'm fiddling with my green screen, you might want to bookmark this page, eltons.show, which is where you'll find all the details of all the episodes. I go into quite a lot of depth in these shows, so if you want a primer around these technologies, I can recommend my books, Learn Docker in a Month of Lunches, and Learn Kubernetes in a Month of Lunches. And if you just want to see what I'm up to, then you can check out my blog, blog.sixside.com. And now, back to the show. Okay, so here I am over here now. So this is the Visual Studio Code setting. This is what I'll be doing the whole rest of the episode. These are the docs that I've got for the demos that I'm going to walk through. So I'll be just running through these demos, showing you what all this stuff does, and hopefully you get a feel for how this works. I'm going to be using 2 different container platforms in the cloud that both run on Azure. So Microsoft Azure, there are a whole ton of different ways you can run containers. I'm going to be looking at Azure container instances, which are like a kind of paths for containers. So you spin up a container, you don't need to worry about the host where it's running. You don't need to manage a cluster or anything like that. It comes with a full SLA and all that sort of stuff. So you can run your production applications in containers without having to worry about managing the stuff the container runs on. And then like the other end of the spectrum in terms of managed platform, which can run containers for you, is AKS. So that's the Azure Kubernetes service. So with AKS, you can spin up a cluster which has a hybrid mixture of Windows servers and Linux servers. And between those, you can deploy a mixture of Windows and Linux workloads. That's what we're going to be showing today. So it's this stuff. These capabilities are not exclusive to Azure. I use Azure because I'm an Azure MVP. Azure is the cloud I'm most familiar with, but of course AWS and Google Cloud, they both have similar offerings. So you can spin up a managed Kubernetes cluster with Windows and Linux servers in Google and Amazon. And Amazon have an equivalent of ACI called Firegate, which just lets you spin up containers without worrying about the underlying platform beneath that. So you can do this stuff in the other clouds too. Okay, cool. So we're going to spin up along here. So there's a whole bunch of links here at the top for the things that I'm talking about. If it's new to you, one of the episodes, one of the demos I'll be running will be using a multi-architecture image, so an image that's packaged to run on Linux or Windows. If you're not familiar with that, then check out this episode of my Docker in a Month of Lunches series, and then the other links are for the source code for the apps you're going to be running. There are 2 ways you can work with these things. So when you're working with Azure, you've got the Azure portal, and then you've got some kind of automation language. So Azure has its own command line, AZ, the Azure command line. There's also PowerShell command. You can run things in, you can describe things in ARM templates to manage your deployment. I'll be using the AZ command predominantly, but I'll show you what these things look like in the portal as well. So first of all, I'm going to spin up my Azure portal over here, Where is that thing? Here we go. Okay, I'm going to create an Azure container instance, which is going to run SQL Server in a Windows container. So just like I've done other episodes when I've run that locally, I'm going to do that in Azure. I'm going to show you through the UI, but I don't tend to use the UI much because it's not repeatable. So UI is a great way to explore the options to see what kind of things you can do. And then I'm just going to translate that and run it in an AZ command. Okay, so I'm gonna this is the container instance blade. If I was at the home, I can go along here, and then the services that are all these here. So I'm gonna go to container instances. These are the ones I used most recently. Create container instances. I've got a whole bunch of options when this screen comes back to me. I'm gonna grab my other screen and put it over here so I can see what I'm meant to be doing. Okay, so first thing is I need to choose a resource group. So if you're not familiar with Azure, all the clouds have some way of grouping together a set of components that represent an application or an environment or what have you. Azure has resource groups. I'm going to create a resource group called ECS-W3. That's the one I've created earlier where I'm going to deploy this. I'm going to create my container. I'm going to call it SQL Server, see if that's available. It can run in East-US, that's fine. And then in ACI, I've got these list of quick start images. So these are Docker container images. Some of them live on the Microsoft Container Registry, or they can live on your own container registry or Docker Hub. I can pick one of these if I just want to get up and running and see what all this does. And you just get a really basic container that's just going to run you a website. I don't want any of that. I don't have my own ACI that I'm going to deploy from. I'm going to deploy from Docker Hub. So all I need to put inside here is the name of the image that I want to deploy. So I'm going to be using my own SQL Server image. This is packaged up on top of Microsoft's Windows Server core image. It's packaged with the SQL Server 2017 Express Edition. So you can run this for production workloads. You might not necessarily run it in a container, but this is really great for non-production environments. Like someone quickly spin me up a SQL Server database that I can access from different offices around the globe. Like you can do this in about 15 minutes. And most of that time will be the container creation time. Okay, so that's my image. I can say that I can tell it it's Windows or Linux, and then I can change the size. I've got a whole bunch of sizing options here. I can go for CPU cores and the amount of memory that I want. If I was running in Linux mode, which I can't for this container image, but the UI doesn't know that yet, I can go and apply a GPU in there, so I can get graphical processing there if I'm doing some kind of machine learning or whatever I'm doing in there. And with these limits look pretty low, but you can obviously get these pumped up. So you can go from hundreds and hundreds of megabytes if you're using GPUs, hundreds of gigabytes for your containers. Okay, so 1 core is fine. I'll bump that up to 2 gig. Click OK, and then next I've got networking. So this is going to let me do the configuration to access this container from the outside world. So when you run a container, the kind of networking is locked down. You can't send traffic in by default when you spin a container up on your machine. It's the same when I'm running an ACI. If I want to let traffic in, I need to map a port. Now the SQL Server port is 1433. And that's a TCP port, so that's fine. I'm going to get rid of the HTTP port that's there by default because I don't need that. I can give it a DNS name, and then I will get a fully qualified domain name. So I'm going to get this East US Azure Container.io as part of my domain name here. And so you give me access remotely from anywhere in the world. So that's all I need to do. So I can set up my DNS level. There are other things I can put in here. I can put my environment variables. So really what I'm doing in this UI is I'm mapping what I would put in my Docker run command into the UI, and I can also map that and model it in different ways too. So I'm going to put in my SQL administrator password. So this will give me access to that machine, and my password is going to be the one that I always use, and that's it. Tags are just key value pairs that you can use to manage your objects in Azure, not necessarily to do with containers. Okay, and that's it. It's going to give me everything I need. I'll click create, and that's going to spin up my Azure container instance. What it's going to do is it's going to find me some host somewhere, and it's going to create my container on that host. It's going to set up the networking for me. It's going to set up all the environment variables, all that sort of thing. And it's all completely managed. I don't know what that's running on. It could be running on some Uber Kubernetes cluster that's running somewhere. It could be using Service Fabric. I don't know. I don't particularly need to care. It's all something up and running. So I go back home, click on container instances. It'll take a little while to show up inside here. And then when it does show up, it isn't going to be running straight away. So what it's doing is it's going to pull down that SQL Server image. If I go and open up the link to where my SQL Server is here. So this is the image on Docker Hub. If I open that in a new tab. And what we'll see is it's quite a big image. So it's Windows Server Core. So we've talked about that in previous episodes. It's pretty much all of Windows Server 2019. And then on top of that, if I look at this tag for my 2017 tag, I'll zoom in a little bit here. We can see that some of these layers are coming from the base image. So this stuff here, this apply image 1809 and install the update. That's part of the Windows Server core image. So those layers will come from MCR. So they're coming from Microsoft Data Center somewhere. So within, within the scope of where my containers are running. But the next bits are bits that I packaged up myself. So these layers here, this 400 megabyte compressed layer, that's living on Docker Hub. So there's a transfer delay. So ideally, when you're running your applications in production, if you're running them in the cloud, then you're going to want to spin up your own container registry local to where your applications are running. So because I'm running on Azure, I'm probably going to spin up an Azure container registry. If I was running in AWS, I'd spin up an Amazon container registry so that my image layers are local to where my applications are running. So I'm moving that data nearer to the compute. Okay, so that's download is going to happen. So if I now go back here, I should see my container instance. Okay, so there's my SQL Server instance that I've just created. If I go and look into this, you can have multiple containers within your Azure container instance. You can kind of model it so that this container instance is like a group that can have multiple containers that all talk to each other internally. I've only got one inside here, and we can see here, oh, it's actually pulled this, that's quick. It's much quicker than when I ran it earlier. So we can see so inside here, these are the list of my containers that are inside this container instance. And then I've looked at the events here, and it tells me all these things that are happening. So it's been created, it started pulling my image, it's pulled the image, and now it's started my application. So we can see here, it's created at 15:11 and 25 seconds. And it's been started at 15:11 and 40 seconds. So the pull started at 15:09. So it takes a couple of minutes to get up and running. That's purely because of the size of the image. Okay, so now if I go and connect to that SQL Server instance, I've got my really lightweight SQL Server UI here. So I've already got this set up using the same SQL Server address that I put in earlier. So that's what I put in as my fully qualified domain name. There's my port and there's my password. So if I test this, that's all up and running. So the connection is all fine. So we can get to that SQL Server because it's just a published port inside the container. It's just SQL Server. It's just a remote database, happens to be running in a container in the cloud. So I can connect to this and I can kind of do whatever I need to do. So I can do a create database ECS and click on execute. I've got this, it's a fully operational SQL Server instance. It's empty to start with. If I disconnect now and connect again, and what I'll see here is there's my new database. So I can work with this in any way that I would normally work with. I can have multiple containers inside that instance. They can connect to each other to model a distributed application. So nice and simple, just a really quick demo that it's an older Windows application. So it's kind of packaged up to run in a Docker file using the similar techniques that I've shown you before in these episodes. And it's just up and running. It's just really quick to get up and running with, and cheap to run because you only pay for the compute instance for that container for the time that your container is running. Okay, but obviously using the UI is not great. So the alternative is to use the AZ command line. So spin back over here. Let's go up to what I'm going to do here. So I'll open my command line here. If you're not familiar with it, AZ, it's a command line for all of your Azure resources. All the clouds have some sort of command line. You do like an AZ login command to connect. I've already done all that and set myself up. So if I want to work with container instances, then I can use a command like this one here. So AZ container create. Going to create me a new container instance, and I can put in all the stuff that you've just seen me put into the Azure portal, which is really a mashup of the things that Azure needs to know and the things that I would ordinarily put in my Docker run command. So there's my image that I'm going to use. This is a really simple web server that just tells you the operating system that it's running on inside the container. I can tell it the OS type is Windows. I can tell it how much CPU and memory that I want, and then I can, same sort of thing, publish the ports and give it a DNS label, which will become the fully qualified domain name. So I can take this. It's going to do exactly the same kind of thing. It's going to run a Windows container. This one's based on Windows NanoServer. So it's a .NET Core, ASP.NET Core web application, but it's based on NanoServer, so it's nice and small. Instead of the kind of 4 gigabyte image that needs to be pulled, in total it's a couple of hundred megabytes, so it's going to be a lot quicker to start up and a lot quicker to get up and running. What I can see here in the output is that this is a kind of an interactive command. So while the container is being created, my command line is going to sit there and just wait for it to be up and running and spinning up. If I switch back to my portal and go back to my container instances, and refresh here is the port. Yeah, so there's my new Who Am I container. So that's the one I've just spun up. We can see that it kind of operates in the same way. There's my fully qualified domain name that I've put in there. So that's available to me. It's allocated a public IP address, and I've already published my port. So that's all looking good. If I go and look at the container events here, I can see it's been started, created, pulling. So it's pulled everything much more quickly. So the difference between, if I switch to UTC, then I can see the timestamps better. So 1446 is when everything began, and 1505 is when it started. So it took 20 seconds instead of 2 minutes because it's a much smaller container image. And when I said right at the beginning of episode ECS-W3, when you're packaging your Windows apps, the first thing you need to assess is, can I run this in a NanoServer container image? Because if I can, you're going to get a much better experience when you do things like this. So it takes 20 seconds to pull instead of 2 minutes. Okay, so that's up and running. I've used the command line for that, but now it runs in exactly the same way. So I can browse to this application here, which is my Who Am I app. So this is the fully qualified domain name for my application. It tells me a little bit about what's running inside the container. So it knows that it's running on, excuse me, knows that it's running on a 64-bit Intel machine, that it's Microsoft Windows, and it's based on 17763, which is quite an old version of Windows, actually, which is when I packaged up this particular image for my Docker book. And then this is the container name. So you can see this is this kind of elaborately generated container name that I'm getting from ACI. I always see a different format of container name if I ran this in Docker or if I ran it in Kubernetes. So this is telling me a little bit about the platform. I can see in here is this CAS, which may or may not be a random name, or it may stand for Containers as a Service. So that's up and running. My Windows containers now up and running in Azure. But there's a disconnect between my workflow here, because I'm using Docker to package up my application. So I've got my Docker file, got my Docker commands when I'm running locally. I'm going to the cloud, and I'm either using this click portal, which I'm probably not going to do in production, or I'm using the AZ command line. There's obviously a disconnect. There's a separate set of tools to learn. So recently, and currently, this is a beta feature in the Docker Desktop Edge release. The Docker team have been working with the Azure team over at Microsoft, and also with Amazon to have a similar experience where you can create and manage containers in ACI using your Docker command line, which is really, really nice way of being able to manage these things, because it gives you a production grade platform without having to manage an orchestrator, because all that stuff's taken care of for you, but you're using your standard Docker command line. So the way you do that, there's a link right at the top of the docs for this page to this deploying to ACI from Docker, from the Docker documentation. I've already set that up, but basically you need the latest beta edition, the latest Edge edition. You can do a Docker login Azure command, and that takes you to the ordinary Azure login page, and then you create a Docker context. Now, I've done a YouTube video about Docker contexts. They're just a way to switch from one Docker server to another Docker server. And the work that Docker have been doing with Microsoft is to present ACI with a kind of Docker Engine-y API. So it can talk to the Docker command line, can talk to it as if it was a remote engine. So I've already set that up. So if I do Docker context list here, what we'll see here is I've got a bunch of things that I have that I use locally, and then somewhere in here I've got my ECS-W3, which is an ACI context type, and it tells me where it's connected to. So this is the resource group. So my context for my ACI containers is a resource group and an Azure region, so that I can manage everything within that group and spin up my containers. So let's see what I've got here. So if I switch to using that context, so Docker context used is going to set my local Docker command line to talk to my remote engine, which in this case is ACI. If I do a Docker PS and just list out all my containers, then there's a little bit of a network lag, because obviously I'm not talking locally to my local Docker server. I'm talking up to the cloud here, and we can see here are the things that I started up. So SQL Server, and who am I? I can see the ports they've been published on and the public IP addresses, and I can see the images, all the usual things I would see when I'm working with my Docker containers. These just happen to be running in a completely managed container platform in the cloud. They have these two names because of this idea of container groups that can have multiple containers. So the container group is the first part, and the container itself is the second part. So I can look at those containers. I can go and look at the logs here. So if I get my container logs for the Who Am I container, I've already browsed to that, but it's a high level of logging, so I don't see all the access logs. It just tells me all the basic stuff about where this is running. You can see the content root is C:\\. So this really is a Windows container. It's running up in Windows. Just happens to be an ACI. Okay, now if I clear this down, actually, let me just show you that. If I do a Docker inspect for that Who Am I container, Docker inspect, it's going to tell me the platform is Windows. It tells me the ports that are available to it, the restart policy. So with ACI, I can say that I want this the standard Docker restart policy always gets observed. So if the app fails, then the container can restart and all that sort of stuff. You'll see if you're used to the Docker inspect command, usually there's a ton more detail that comes out in the JSON here. I'm only seeing part of it because this is all that the API version of the Docker engine, the ACI version of the Docker engine gives me. So it just gives me a subset of stuff here. but I can see that my platform is Windows. Okay, cool. So now if I run a new container, so I'm still using the Docker command line. I'm going to run that same Docker container image. This is the multi-architecture image. So when I created it with ACI, with my AZ command, I said I wanted it to run on the platform Windows. So it would have spun up on a Windows host to pull this image. I'm not specifying the host this time, so the platform this time. So I'm just specifying this image name, which is a multi-architecture image. I want to publish my port. I'm going to give it a name, who am I to? Okay, so you get this awesome UI. I don't know if this is intentional. It's just the way, because I'm running this inside a terminal that's PowerShell inside Visual Studio Code. But you get this thing that just it's kind of difficult to tell you what it's doing. It's creating the container group, and then it's going to create the container inside there. And it just it obviously does a polling update, but instead of updating the same line, I get these millions of lines come out. Like I said, it's a beta feature. And we think about what it's doing behind the scenes, the fact that it's just like superbly creating these containers in a production container platform from a single line, which is the same line I would run locally. Okay, so there's my thing. There's my who am I to. If I go and do my Docker PS again, I should see my new container in there. So because I created this directly with Docker and I gave the container a name, I don't have that double container name business, but I've already got my IP address allocated. I've got the port published, so that's all looking good. So now if I curl this, just to see what I'm getting, I get operating system Linux. So I'm getting the Linux version. So because I used the multi-architecture image, that's what's being, and by default, when I create through the Docker command line, I'm connected to an ACI context, I'm going to get Linux containers out. Now, Docker does kind of support this platform flag, but that's not integrated with ACI right now. So if I try and do, if I try and pass it the -- platform flag, it'll throw me an error. And also because it's early stage of this integration, I know that I can run a Windows container in ACI. I can manage those Windows containers in ACI, but I can't create them with the Docker integration just yet. So if I try and run, again, same sort of command, if I run who am I, but I run the specific tag, which is for my Windows image. So this is not a multi-architecture image. This is just Windows. I'll still get a whole bunch of stuff comes out. And then at the end, it'll throw me an error and it'll say I can't run this because it says the specified OS Linux, and this container image is for Windows. So it doesn't support it's trying to schedule that container to run on a Linux host, and it's a Windows container image. So because the Docker integration doesn't let me specify the platform yet, it doesn't let me do all the things I could do with the AZ command or with the portal. But really promising stuff. Hopefully this will get some traction. It'll be developed even further. You can use this with Docker Compose as well. So I can have a Docker Compose file that specifies all my bits and pieces that I'm running locally with Docker Compose up. And when I switch my context to use an ACI context and I do Docker Compose up, then everything gets created in those Azure container instances in the same container group. So it's it's that SLA for production. It's that super easy, lightweight way to manage it because I'm using the same modeling specification, the same tools that I use locally, but I'm using the Docker's integration with ACI. So it's really, really cool. So yeah, at the moment that the ACI integration is in beta, so it doesn't have the full Windows support. You can create Windows containers using the Azure tools and manage them using Docker. You can't manage them and create them yet. The whole stack using Docker. The other thing that's slightly weird is if I try and remove all of my containers, so I'm still connected to my ACI context, I can run my Docker RMF command, which is going to remove any running containers. It'll remove the one that I created using Docker run. So that's my who am I to has been removed. The others, it says I can't delete the service because it thinks it's a Compose project because it's part of that nested thing. So my SQL Server container is part of the SQL Server container group. So for that, I need to do a Docker Compose down. And if you've got a keen eye, you'll see this is a slightly different Docker Compose command because it doesn't have the dash. So Docker Compose is becoming a verb inside the ordinary Docker CLI. So I can use Docker Compose down to take these things down. I'm still talking to ACI, so it's removing all those ACI container groups and getting rid of those containers. So that's all been removed now. If I go back to my portal, go back to my container instances and refresh. It takes a little while for the UI to catch up with everything, but we'll see my who am I to is gone now. If I keep on refreshing this, then the SQL Server and the who am I will go. But obviously, we've got a limited amount of time. I'm not just going to keep refreshing. If I do a Docker PS instead, because my context is set to be ACI, then I'll see that there's nothing up and running there. Okay, cool. So ACI, the equivalent in Amazon is called Firegate. It's a kind of, it's containers as a service. You're just going to bring your container definition, whether you're using the AZ command line or a Docker Compose file, or whether you're using the Docker command line, then you're just going to spin them up and they get managed for you. So I don't have to worry about a virtual machine going down. I don't have to worry about, a problem with the region, the data center. I'm purely the SLA that I'm asking for is based on running this container, and then everything else gets taken care of for me. It's a really nice way of, if you've got production requirements to run your containers, but you don't need the full flexibility of something like Kubernetes, and you don't need all the overhead of managing the complexity of your application model, because Kubernetes lets you do all sorts of fantastic stuff. Not every application, not every organization is going to need that. So by kind of getting rid of the orchestration layer, then you take your Docker Compose file that you use locally and in your test environments, and use the same thing in the cloud with your ACI or your Firegate integrations. Is really, really nice, promising way to look at things in the future. But without that, you can still spin things up and run them in ACI or Firegate using the cloud's tools. You're still going to use the same Docker container images, but you'll be creating them with AZ command or whatever else you're using. But the Docker Compose integration, which is really new, is looking good already. So hopefully that'll be a nice production alternative in the future. Okay, and then the other end of the spectrum of kind of complexity and setting things up is to use a managed Kubernetes service. So if you're looking at Kubernetes, then the modeling language lets you configure all sorts of interesting tweaks, and we'll have a look at some of those files later on in the episode. But the platform itself, ideally, if you're spinning up in the cloud, it's a managed platform, so you're not going to worry too much about how you have to look after the VMs or deploying Kubernetes itself or connecting the cluster together. If you're running in the data center, you do have to worry about that, and that is not a small undertaking. But if you're looking at Kubernetes in the cloud, then all the clouds have a managed Kubernetes instance. So if I go to the Kubernetes services here, I've already got a couple running because my blog runs on Kubernetes, obviously. I've already set up the one for today's session because it takes a little while to set up, but I'll show you what it looks like. I can go to add Kubernetes cluster. With Azure, you can also take a local Kubernetes cluster and connect it to your Azure command line, your Azure portal, so that you can manage that cluster and you can see the cluster inside Azure. So it behaves as an Azure resource, even though it's your local Kubernetes cluster, which is a topic for another day. So same sort of thing. If I'm creating through the portal, I need to select a resource group where all these things live. Give the cluster a name, and then the thing that's interesting about when I'm creating this for a cloud deployment is that in Azure I need to have multiple node pools, so groups of nodes that are the servers that are going to run my application containers. So if I want to have some Windows and some Linux, then I've got to start off with a Linux node pool. So by default, I'm going to start. I can scale this up or down as many nodes as I want. So I'm going to go down. I've got one node pool in my default node pool, which is my Linux, my primary node pool. I can add a new node pool, and I can say this is going to be Windows. And this is how I get this hybrid cluster. The user experience is different in different clouds, but the end result is the same. I'm going to have a Kubernetes cluster, a single Kubernetes instance with multiple nodes. Some of those nodes are going to be Windows, and I'll run my older Windows workloads on those. Others will be Linux. And this is fantastic if I'm moving existing applications to the cloud and I want to run them in containers in a portable way. I can do that with Kubernetes. And if I've got my older Windows estate, if I want to reduce my Windows footprint over time, then all I'm going to do is I'm going to spin these sliders. And I'm going to go from having 10 Windows nodes and 2 Linux nodes. I'm going to gradually move to maybe 5 Linux nodes and maybe just 2 or 3 Windows nodes and spread the workloads around. As I'm moving from maybe .NET Framework to .NET Core or .NET 5, then I can move those to Linux workloads. And the only real difference is a couple of lines in the Kubernetes YAML, which I'll show you in a second. So that's all I really do is I want Windows nodes, I set how many nodes I want, and then I choose a size, which is just the VM size for the nodes. I'm not going to do that because I've already got that set up and running, and I did it with the Azure command line again. So let's open this up so you can see how this looks. It's a couple of different steps when you're doing the AZ command line, because first of all, you create the cluster, and you can take these things and paste them straight into your own AZ command if you want to do that. There's the resource group that I've already created. The Kubernetes version that I want it to run. Azure are really good, and all the clouds are really good about keeping up to date, so I can run 1.18. The new release is 1.19. That's available in preview. And then if I want to run Windows nodes, I need to provide the Windows administrator username and password. So the first step is to create the cluster, which will give me a Linux node pool, the primary node pool. And then if I scroll down here, then I'm going to run another command to create a new node pool. So this is the node pool add, which will give me the Windows, will give me my Windows servers. So inside here, I'm saying the OS type is Windows. There's my node count, and then I can specify the VM size and all that sort of stuff as well. I've already done that, so my credentials, my cluster's already up and running, because provisioning the cluster and setting up all the VMs and connecting everything takes a few minutes. So rather than sit here and wait for that to happen, I've already done that. Then you're going to run this command, which will take the credentials to connect to that Kubernetes cluster and put them in your local kube config so that I can use my local kubectl command, which I get with Docker Desktop, to connect to my remote Kubernetes cluster, just like I'm using Docker to connect to ACI. So I'm going to do my AZ get credentials. So I'm already logged into my AZ, to my Azure subscription, so it's going to go and get the credentials and merge them into my local kube config. I don't need to authenticate again because that's already in there. And now if I run kubectl get nodes, then I'll see that I've got a whole bunch of things in here. So I created this a couple of hours ago. So this is my default node pool. These are my Linux nodes, and here are my Windows nodes. They're all running the same version of Kubernetes. It's all one cluster. Kubernetes doesn't really care as far as it's concerned. It's got a bunch of machines that are all running the kubelet, that are all feeding back all the same information. Just some happen to be running the Windows operating system. Okay, so in order to deploy to my Windows, I've got a really old application that I'm going to deploy. It's the .NET Pet Shop. That link there will take you to the source code. I grabbed it from Codeplex. So Codeplex kind of was Microsoft's way of distributing code many years ago, and Pet Shop was on there, and it's just a really simple application that tried to showcase some of the earlier .NET features. This is from 2008 using .NET 3.5, an old application. You can go and browse the code that I think I made like one code change just to package things up so they work more neatly in containers, and that was about it. And then I've just built them into Windows container images on top of those Microsoft images that we've already seen in the series. I'm going to deploy it to Kubernetes. Now, inside the docs and the demos for this episode, inside the W3 folder, there's a whole bunch of Kubernetes stuff. And if you're not familiar with Kubernetes, then you can kind of skip over a lot of this stuff. What I've got here is I've got two things that I'm going to deploy. I'm going to deploy an ingress controller, which is the thing that's going to run in Linux containers on my Kubernetes cluster, and it's going to receive all the incoming network traffic. And an ingress controller is just with Kubernetes. That's how you map a bunch of rules to say, I've got one central component listening for all incoming traffic. So I can have, just port 80 available across my entire cluster. Any traffic comes in, one of those Linux containers will pick it up. I'm going to have a whole bunch of rules that say, if you get a request for this path or this domain name, here's the container, here's the pod that you're going to get the data from. So it's just like, it's a reverse proxy. If you've seen me talk about that stuff before, it's a reverse proxy, but it's managed in a way that it becomes a first-class resource in Kubernetes called ingress. So that's all that stuff is in there. The only thing I'm going to show you inside here is in my ingress controller. And if you're not familiar with Kubernetes, this is just a massive lump of YAML you can more or less ignore. I'm not showing you this to show how much stuff I know. This is just how you set things up. There's some good best practices in here. And one of the things I want to show you is inside here, this node selector. So this is the bit that says to Kubernetes, this is a Linux workload. You need to run this on the Linux machines in the cluster. So as part of the cluster, every machine has a whole bunch of labels. Kubernetes is very big on labels. They're just key value pairs. Some of them are generated by the platform. Some you can apply yourself. Every node has an operating system label. So when it gets set up, when it joins the cluster, Kubernetes knows whether it's Linux or Windows. It also knows whether it's Intel or ARM, or a whole bunch of other things. This is saying that the node selector here, these pods, these containers have to run on a Linux server. So my ingress controller, my network traffic will come into the Linux containers. So I'm going to deploy that in a second. And then I've got my Pet Shop application itself. So I've got a SQL Server database that's going to run. We can see in here, this is the container image. So again, it's just an ordinary Docker Hub image, this public image on Docker Hub. I've got things in here like my environment variables for the administrator password, but I'm getting that from a secret in Kubernetes. So if you are interested in Kubernetes and you want to see how Windows workloads get mapped out and modeled out, have a look at this stuff. You'll see there isn't much difference from what you're normally doing. I'm taking secrets that I create in Kubernetes. I'm taking config maps from my application configuration, all the usual stuff, all the stuff you would do in a production deployment of Kubernetes. It's the same for Windows. The only thing that's different is down here. I've got my node selector that's saying I'm going to use the operating system Windows. And that's really it. This is the only big difference between my Windows application components and my Linux application components. All the rest of the stuff, like I can specify how much CPU I expect my application to use. I can specify the limits that should be applied so it doesn't, if something happens to my container application and it goes rogue, that it doesn't start taking down all the services, all the compute application, all the compute resources on the node. I can specify all that stuff. So all these production-y things, all these best practices are the same with your Windows workloads in Kubernetes as they are for Linux. The only thing that's different is your node selector. Okay, cool. I've got the same thing here for my web application. This is just publishing a service, which is how traffic is going to get from my ingress controller to my application. I've got 2 replicas here, so I can scale up, so I can run it across my multiple containers. I've got the other stuff down in here, all the stuff you would normally expect to see. So these are my volume mounts for configuration. So I'm loading configuration from Kubernetes into my application container, and then my application reads it from there. I've got those same sorts of, I've got readiness probes and health probes so that Kubernetes can test if the application is healthy. Down here, I'm loading in those configs. Then I've got that node selector again. And I've got, and this is just to show you that you can do the same stuff with Windows that you do with Linux. So Kubernetes has this concept of affinity, which says that this pod, which is just a wrapper for one or more containers, this pod should run nearby this other pod, or should run far away from this other pod for high availability. And what I'm saying here, I'm adding some affinity that says my application here, my pet shop web application, should have a, what am I doing here? I'm doing anti-affinity, so it shouldn't run next to another one in the same zone. So it's a very complicated way of saying if I have multiple nodes in my cluster and they're running in different availability zones. So all the clouds have this notion of availability zones. Think of it like different racks inside your data center. So I don't want all my pods running on servers in the same rack, because if that rack goes, then I lose everything. This is a way of saying I want the pods that are running this application to be spread across different racks, different zones, and that's all that's doing. It's quite a complicated little bit of YAML in there, but it's very flexible because it lets you say I don't want my applications to be co-located in the same server or the same rack, or however I have my topology defined. Or you can say things like, I do want my web application pods to be next to my API pods to reduce network traffic. So I'm only showing you this to show you that the whole API spec of Kubernetes, almost all of it applies to Windows containers in the same way that it does to Linux containers. Okay, cool. So let's go and actually deploy this so we can see how it looks. So let's get rid of that browser. Let's get rid of that. Let's bring the terminal back and clear this down. So right now I've got nothing deployed. So I've got my nodes up and running. I cleared everything down. So each of these things is going to live inside its own namespace. And right now I don't have any namespaces, any custom namespaces. So let's go to where all those YAML files are. And if you're completely unfamiliar with Kubernetes, this is how you deploy stuff in Kubernetes. So kubectl apply, I'm giving it a path, a folder path, which is where all those YAML files are for the ingress component. So this is the reverse proxy. It's listening across the cluster. Any traffic that comes in, it'll decide what to do with it. And it's deployed all that stuff, so that's all cool. Those things will run in Linux containers. If I go and look at the pods for my ingress, then what I should see is they're all up and running. They're all ready, so that's all looking good. It'll take a few seconds. Small Linux containers. I've already done a kind of dry run of this using this same cluster. So all the container images have already been downloaded. So they're already on those nodes. So everything should start up pretty quickly. Okay, so let's clear this down. Now if I deploy the pet shop app, it's the same process. They're split into different folders just because I want to manage them in different ways. I could put everything in one big YAML file if I really wanted to. But the fact that these are Windows components makes no difference. I'm still creating all these same sort of Kubernetes resources, secrets, which are where my database password lives, which have a mechanism to mean that I can separate the people who can work with those things. So not everyone will be able to see those secrets. Configuration maps, which is where I'm putting my XML config for my web applications. And then the thing that I didn't show you, which I should show you, are my ingress rules. So my ingress rules for the web application here. This is the bit that says, with the ingress controller, you're listening for traffic. When you receive a request, I would ordinarily have a domain name in here, but I'm only running one component. So anything that comes into this application, you're going to send it to the pet shop web component, which is going to be my Windows application that's running. And actually, I've got some static things in here. So my pet shop web application is a dynamic web app, but there are a whole bunch of things that could be cached, like images. So I've got another ingress, which says that anything that comes in for these production images or these common images that can still be served by the ingress controller, but it can be cached within the ingress controller. So again, showing you all the flexibility of Kubernetes applies whether you're running Windows apps or Linux apps. Okay, so let's go back to here. So everything should be up and running now, hopefully. If I go and look at the pods for my pet shop. Okay, that's all looking good. So there's my database. There's my 2 web pods. So they're going to be running across different servers because that's what I specified in my topology rules. Now, if I go and look at the service for the ingress controller, the service is just the service is just the network component that listens for incoming traffic. So this is a public load balancer component. Kubernetes integrates really nicely with all the cloud platforms. So when you deploy this specific type of ingress service, that's a load balancer service, then I'm going to get a public IP address that Azure assigns for me. And it depends on which platform you're running, what you actually get. But I'm going to get in Azure, I'm going to get an actual load balancer that's going to span the nodes in my cluster. If I run this same deployment on Docker desktop, I wouldn't be able to run the whole thing because you can't have Linux nodes and Windows nodes on a single Docker desktop machine. But if I ran just the Linux versions, I could still have a load balancer IP, and the external IP address would be localhost. So I can kind of get the same thing with the same YAML files. Okay, so this external IP address should be something I can browse to. Let's go up here and open this up. Hey, okay, there we go. Okay, so this is the pet shop from 2008. I've taken the code that was on Coplex, packaged it in a Docker image, written a whole bunch of YAML to run it in Kubernetes with a whole bunch of Kubernetes best practices, and it just works. So I can go and look at these things. As I'm looking at the images, these are being cached now in my ingress controller. I've got some other stuff in there. So the pet shop application needs sticky sessions in order for your wish list and your checkout to work. So I've got that specified in my ingress settings. If I go back and look at these again, you should find they're faster because the images are being cached inside the ingress controller. So I've got all the Kubernetes goodness. I've got all the managed platform because I just created my whole Kubernetes cluster with a couple of AZ commands, and I'm deploying using the standard Kubernetes tools. They just happen to be Windows containers. Okay, cool. So hopefully that's kind of giving you a flavor. Well, I need to update that because that's this week, so that's not coming next. So that's an idea of how we can take these Windows applications and run them in the cloud without having to add a whole bunch of ceremony. If I just want something quick or I want something that's fairly simple to model, then I can use ACI, and I'm still going to get a production-grade container platform without having to worry about the modeling language, because I can use Docker Compose, hopefully, at some point in the future if the integration gets extended to Windows containers. And if I do need all those tweaks, or if I need to model things in a complex way that I've got with my pet shop here, I can do that with Kubernetes. And I can just spin up a Kubernetes cluster, add some Windows nodes in there, and then run this hybrid workload. And as you saw, that my ingress controller is running in Linux containers, it's fetching the content from my Windows containers. If my Windows containers were reading from an API that was running in a Linux container, it all just works in the same way. They just use the DNS names of the Kubernetes components, and everything works in the same way. Okay, cool. So we've got some stuff going on in chat. Is there anything interesting here? Why would you use? Okay, so yeah. Hey Mike. Hey Nuno. So Sebastian says, why would you use a container instance instead of a web app based on containers? There's an advantage of one over the other. So Azure has a whole wide range of PaaS offerings to be able to run your applications. Web apps is one of them. So the idea of web apps in the old days was that there was a kind of the fact that it ran in containers was kind of hidden from you, and you brought your code and it packaged it up for you, and it actually ran it in containers under the hood. And then it evolved to let you say, look, I've got my container image, run this container image for me. I think the difference is where the landscape that you're running on. So, if you're using Docker locally, if you're planning to use Docker in your production environments, if you're looking at containers as your primary deployment tool, then I would stick with the most containery thing, which is ACI. ACI also lets you have these container groups. Now, you can't do that in Windows yet, but I could have container groups that effectively let me connect within like a local network, a local Docker network that I can do when I'm running containers locally. So I've got a lot more flexibility in what I can do with ACI. But it means I'm working in a kind of Dockery way instead of a kind of Azure way. So it really depends on what else you've got in your landscape and what other runtimes you're using. But if you're more container focused, then I think ACI will give you some more tweaks. And if you're more of an Azure PaaS focused, then web apps are probably the way to go. But the beauty of it is you can proof of concept that really quickly. So you package your app in a container image and you run it on both, and you see what works for you, what works for your pipelines and your workflow. Okay, cool. So yeah, yeah, awesome. Good. I'm glad it was awesome. So next week is the last one about Windows containers. So remember, the theme is going to run for a month. This month was all about Windows containers. Next month is going to be about orchestration. But before, I've got one last Windows episode. We're going to dig in a little bit more into the detail about what's going on inside those Windows versions that we're looking at. So Windows containers have been around since Windows Server 2016. The versioning story is a little bit involved, so I'm going to get into that so you understand what's happening inside those versions. and talk about isolation, process isolation, Hyper-V isolation, and some of the other kind of quirks like LCAR to run Linux containers on Windows. So that's coming next week. And then after that, when we get into November, it's all going to be about orchestration and comparing different orchestrators. But next week, stay tuned. I hope you found this useful. My name's Elton. This is Elton's.show. And next week, we're going to look at the digging into the details of Windows container versions when you're running with Docker. Okay, thanks.